June 7, 1944, the morning after D-Day. A cold wind sweeps the coast of Normandy, carrying the smell of salt, oil, and iron. The beaches are littered with wreckage, tanks half buried in sand, landing craft twisted by waves, medics crouched over the wounded. Offshore, the channel still churns with smoke and debris. But beyond the chaos, something extraordinary begins to appear on the horizon. Massive concrete blocks, each the size of a ship, drift slowly into position, towed by tugs across the gray water. Behind them come floating steel roadways, rising and falling with the swell. From the cliffs near Arromanches, German spotters stare through binoculars, struggling to comprehend what they're seeing. The Allies are building harbors, not capturing them, but constructing them on the sea itself. Within hours, cranes, ships, and trucks form an industrial miracle on open water. Vessels unload cargo straight onto the floating piers. Tanks roll ashore as if onto solid land. The Germans had planned to defend every port in France. But the invasion no longer needed one. What rose from the waves that week would move more men and machines than any harbor in Europe. And it had been built in secret. In 1942, the Western Allies faced a problem as vast as the war itself: how to land an army on the continent of Europe, and, more importantly, how to keep it supplied. The defeat at Dunkirk 2 years earlier had taught them that courage alone could not sustain an army without ports. The English Channel, narrow yet treacherous, separated Britain from occupied France, and behind those beaches stood one of the most fortified coastlines in history, Hitler's Atlantic Wall, a chain of concrete, guns, and steel stretching from Norway to the Spanish border. Every German commander knew that an invasion would come someday. What they didn't know was how, and the greatest Allied minds didn't yet know either. When the first Allied raid on the French port of Dieppe took place in August 1942, the results were catastrophic. More than half of the 6,000 men who landed were killed, wounded, or captured. The few tanks that reached the town's seawall were trapped and destroyed. The lesson was brutally clear. No port could be seized intact. German demolition teams would destroy every dock, every crane, every bridge before surrendering them. That failure haunted the planners in London and Washington. General Dwight D. Eisenhower and his staff realized that even if the D-Day landing succeeded, victory would collapse within days without a functioning harbor. An army needed food, fuel, ammunition, and reinforcements, not just once, but continuously. A single division required nearly 700 tons of supplies per day. Normandy had no ports capable of handling that. The idea that would change history began not with a general, but with a statesman who thought like an engineer, Winston Churchill. Long before the invasion, as early as 1917, Churchill had written a memo during World War I proposing the use of floating piers for landing troops and stores. It was a concept that seemed fanciful at the time, yet it stayed with him. When the problem returned in the new war, he sent a terse note to the chiefs of staff. They must bring their own harbors with them. That one line became the directive that would lead to one of the greatest feats of engineering ever attempted. What Churchill demanded was unprecedented. The Allies would have to design entire ports, complete with breakwaters, unloading platforms and roadways that could be built in sections in Britain, towed across the Channel, and assembled on the beaches of France under fire. These ports would have to survive the tides of the Channel, one of the roughest stretches of water in the world, and endure weeks of operation before a permanent harbor could be captured. In 1943, under the supervision of Vice Admiral John Hughes Hallett, a team of British engineers, naval architects, and civilian contractors began developing prototypes. Their code name, Mulberry. The project's secrecy was absolute. Test models were hidden along the coasts of Scotland and Wales, guarded by barbed wire and military police. Hundreds of civilian companies were quietly recruited: shipbuilders, concrete firms, steel manufacturers, all contributing parts to something they were not fully allowed to understand. Meanwhile, German intelligence interpreted Allied construction along the British coast as preparations for ordinary amphibious craft. No one in Berlin imagined the Allies were building harbors that could float. Yet that was exactly what was happening, a logistical miracle taking shape in dry docks, quarries and shipyards all across Britain. By late 1943, planners had calculated that 2 complete Mulberry harbors would be needed, one for the American beaches near Omaha and one for the British sector near Arromanches. Each would require over 600,000 tons of concrete and steel, more than the weight of all the warships at Pearl Harbor combined. The Allies were preparing to do something no army had ever done before: create the infrastructure of victory from scratch and tow it into battle. The secret heart of the project lay not in one design, but in many. Mulberry was not a single structure. It was a system, a symphony of engineering components, each performing a specific role. The Allies would need to master hydrodynamics, logistics, and improvisation all at once, under the gaze of German reconnaissance that could never be allowed to understand what was coming. The first element was the breakwater. To shield ships from the violent tides of the Channel, the engineers devised colossal concrete caissons called phoenixes, hollow blocks taller than houses built in dry docks across southern England. When the time came, these monsters would be towed out, flooded with seawater, and sunk in position to form a wall against the surf. Together they would create a calm lagoon where vessels could unload. Next came the bombardons, giant floating steel barriers moored further offshore. Shaped like cruciform rafts, they absorbed the first impact of waves, reducing swell before it reached the inner harbor. Behind them would rest the phoenixes, creating still water in which to build the next miracle: the piers. The piers, codenamed Whales, were articulated steel roadways stretching more than a mile from the open sea to the shore. Each section floated on pontoons known as beetles, connected by hinges so they could rise and fall with the tide. The ends were anchored to pierheads called spuds, 4-legged platforms that could lift themselves up and down on giant hydraulic legs, maintaining a steady surface no matter the tide. Finally, to complete the illusion of permanence, the Allies planned floating road networks linking these piers to the beachhead supply depots. Tanks, jeeps, trucks, and ammunition trailers would roll straight from ships, over the water, and onto French soil, without touching a port. Each piece had to be built in secret, yet in full scale. Across Britain, quarries filled with concrete molds. Shipyards from the Clyde to Southampton turned out endless spans of steel trusses. Thousands of workers, many of them civilians, were sworn to silence. Some thought they were helping to build a new kind of oil pipeline. Others assumed it was part of a bridge project. Few realized they were constructing the backbone of D-Day. The logistics of moving these structures were almost as complex as building them. Once assembled, the components would need to be towed across the Channel, 30 miles of unpredictable current and wind, by fleets of tugboats. Each Phoenix caisson weighed up to 6,000 tons. Each whale roadway could twist and shear if the weather turned rough. In December 1943, Churchill approved full production. 2 complete harbors were ordered: Mulberry A, destined for the American sector at Omaha Beach, and Mulberry B, for the British and Canadian beaches at Arromanches. A third was considered for use near Cherbourg, but later cancelled. By spring 1944, the pieces were ready. In river estuaries and along quiet coasts, lines of phoenixes waited like sleeping giants. Tugs and barges assembled in ports from Portsmouth to Tilbury. The movement of these colossal structures was timed with precision. Any delay would risk German aerial observation. Meanwhile, German reconnaissance flights photographed the southern coast of England, puzzled by the growing number of large concrete forms along the shore. Analysts in occupied France theorized that they might be components of anti-invasion defenses or experimental docks. No one guessed the truth, that they were invasion harbors, ready to be floated across the sea. In May 1944, just weeks before D-Day, final rehearsals were conducted off the coast of Scotland under strict secrecy. The prototypes performed flawlessly. The engineers had proven that entire ports could be assembled, disassembled, and towed, a concept that defied every maritime tradition. As the invasion fleet gathered in the final days before June 6th, the Mulberries waited in silence. Their purpose was known only to a handful of officers. They were not meant to land first, but to follow, to give the invasion permanence. When the first troops stormed ashore in Normandy, the Mulberries would be waiting just beyond the horizon, the final act of deception and the greatest feat of wartime construction ever attempted. The Germans expected beaches to yield blood, not infrastructure. They would soon watch in disbelief as entire harbors rose from the sea. The Mulberry harbors were not simply engineering marvels. They were an expression of Allied resolve, ingenuity, and cooperation on a scale the world had never witnessed. Every element of the operation combined human daring with industrial precision. To make them work required coordination between navies, armies, engineers, shipbuilders, and dock workers, all operating under total secrecy and immense pressure. From the engineering angle, the project bordered on the impossible. The English Channel was one of the most hostile environments imaginable. Fierce tides, shifting sands, unpredictable weather, and a tidal range that could rise and fall by nearly 20 feet. The structures would have to remain steady in such chaos while enduring the hammering of thousands of tons of cargo. Designers at the British War Office studied every variable: water depth, current, anchorage strength, and the geometry of steel trusses. They built scale models in wave tanks and used wind tunnels to test stress points. The biggest challenge was flexibility. The roadways had to move with the sea but not break apart under it. Engineer Alan Beckett, a quiet genius from the Ministry of Supply, designed the solution: an ingenious bridge section using rotating steel joints that flexed like vertebrae. His whale roadways would become the backbone of the entire harbor system. The Phoenix caissons, meanwhile, were feats of brute industrial power. Each one, a concrete block longer than a football field, was hollow, compartmentalized, and watertight. Tugboats would tow them to Normandy, where valves would open to flood the compartments, sinking them into place with precision measured in feet. Once aligned in rows, they created breakwaters rivaling the walls of ancient fortresses. On the tactical level, Mulberry was the linchpin of Operation Overlord. Without it, the invasion could not be sustained. Allied planners estimated that they needed to unload at least 12,000 tons of supplies every day to maintain momentum after D-Day. The beaches themselves could not handle that. Not with tides washing away landing craft and storms constantly threatening to isolate them. Mulberry turned those beaches into functioning ports. In the first week after D-Day, the Allies landed over 300,000 men and 54,000 vehicles. By conventional means, such a feat would have required multiple ports. Instead, the floating harbors handled the burden seamlessly. Ships could berth offshore, unload directly onto the floating causeways, and depart without anchoring. Even during rough seas, the flexible piers held. It was an operation that combined fluidity with structure, chaos with control. The naval coordination behind the project was staggering. Over 200 tugboats were required to tow the individual pieces across the channel, a journey of 30 miles that could take days depending on weather. The convoy stretched across the horizon. Concrete blocks, steel spans, pontoons, and pierheads moving like a slow mechanical armada. To protect them from air and submarine attack, destroyers and minesweepers escorted the formation all the way to Normandy. Timing was everything. The harbors had to arrive after the beaches were secured but before supplies ran out. Delays could mean disaster. Communication between engineers, naval crews, and army units was conducted in coded messages and precise timetables. The entire assembly sequence was rehearsed down to the minute. From the logistical angle, Mulberry represented an audacious gamble, transporting an entire industrial complex across a body of water. Each unit had to fit perfectly with the next. The British Ministry of Works oversaw the manufacturing, while the U.S. Army Corps of Engineers provided reinforcement and coordination. Factories that once built bridges or railway girders were repurposed overnight. Even the materials had to be rationed with wartime discipline. Britain's steel supply was already strained by shipbuilding demands, and concrete was scarce. Yet thousands of tons were allocated to Mulberry because the invasion depended on it. As Churchill put it, "Victory will rest upon the ports we build." The psychological dimension was equally significant. For the soldiers preparing to cross the Channel, Mulberry meant survival. They knew that behind them would come the lifeline: fuel, ammunition, and reinforcements delivered regardless of weather or German sabotage. The harbor symbolized security in an uncertain world. For the commanders, it represented audacity, proof that the Allies could think beyond the constraints of geography. The Germans had spent years fortifying every existing port along the Atlantic, but by creating their own, the Allies rendered that entire strategy obsolete in a single stroke. By June 5, 1944, the eve of D-Day, over 400 individual components lay moored along Britain's southern coast, waiting for the order to depart. To anyone watching, it must have seemed impossible that such a chaotic collection of shapes and structures could form a working harbor. But to the men who built them, every bolt and hinge had purpose. When the order came to move, it was like watching a miracle unfold. The steel whales, the concrete phoenixes, and the floating beetles began their slow procession across the sea, an armada of invention heading toward history. And somewhere on the cliffs of Normandy, German observers would soon watch through their binoculars and see what they had never expected: ports where none had existed, built not by nature or by time, but by human imagination. When the first Mulberry components appeared off the Normandy coast, few Allied soldiers understood the scale of what they were witnessing. For days, tugs and barges had been towing strange shapes across the channel: floating blocks, steel skeletons, box-like pontoons, with no explanation. Then, suddenly, as the wind shifted, the pieces began to align. Cranes swung, cables tightened, and the sea itself seemed to harden into structure. From the beaches, troops stared in disbelief. Out of open water, harbors were forming. The human angle of the operation was one of exhaustion, danger, and ingenuity. Royal Engineers and U.S. Navy Seabees, the construction battalions of the Pacific now redeployed for Europe, worked day and night under enemy fire to assemble the floating ports. Every hour mattered. German artillery from inland batteries lobbed shells toward the coastline, trying to disrupt what they thought were temporary docks. They didn't yet realize that these were the arteries of an entire invasion. Each caisson had to be sunk in sequence and welded to the next. Crews used depth charges to settle the blocks evenly on the seabed, diving into cold, fuel-stained water to fix anchors by hand. The men worked waist-deep in the surf, dodging wreckage and shells, guiding the immense structures into place using little more than ropes, pulleys, and instinct. At night, searchlights were forbidden. The crews worked by feel and by timing, counting waves to guess their moments. For every visible triumph, a pier connected, a pontoon leveled. There were hidden tragedies: men crushed between concrete walls, drowned by sudden currents, or lost to exhaustion before the work was complete. Yet, in barely 6 days after D-Day, both harbors were functional. Trucks were rolling off ships onto floating roadways. Ammunition, fuel, and food were flowing directly into the Allied front. One observer wrote, "It is as if London docks have been lifted and set down in France." From the German perspective, it was unthinkable. Reconnaissance pilots flying over Arromanches radioed reports of massive offshore structures resembling ports. The Wehrmacht's coastal observers initially dismissed them as wreckage or deception measures. But by the second week of June, it was undeniable. The Allies had somehow built working harbors on the open sea. The intelligence shock reached the German High Command by mid-June. Field Marshal Gerd von Rundstedt, inspecting the defenses, reportedly said, "We prepared for an army. We did not prepare for engineers." The Germans had built their Atlantic Wall to destroy invaders before they gained a port. The Mulberries had made that entire defensive concept obsolete. In Berlin, reports described man-made islands off the Normandy coast. Technicians within the Kriegsmarine attempted to interpret aerial photographs but couldn't fathom how such structures stayed afloat. To them, it seemed as though the Allies had defied the laws of the sea. Meanwhile, for the Allies, the strategic impact was immediate. Within 2 weeks, the two Mulberry harbors were unloading more than 12,000 tons of supplies daily. By July, the figure exceeded 18,000 tons. Fuel, rations, munitions, and vehicles flowing into France at a rate that stunned even their own planners. The Americans named their harbor at Omaha Mulberry A, and the British called theirs at Arromanches Mulberry B. Between them, they created a logistical bridge so efficient that by the time Cherbourg's port was finally captured, the Allies no longer depended on it. The beaches themselves had become self-sustaining industrial zones. The moral effect on Allied troops was profound. Soldiers who had expected weeks of hunger and shortage found the beaches overflowing with crates, food, and ammunition. The steady rhythm of convoys, Liberty ships arriving, unloading, departing, gave a sense of invincibility. The Mulberries were more than structures. They were reassurance made real, proof that no storm or setback could starve the invasion. And yet the men who built them received little recognition. Engineers seldom do. When veterans spoke of Normandy, they remembered the paratroopers, the tanks, the generals, not the welders and divers who pieced together the roads that carried victory inland. But without those floating roads, the tanks and trucks would never have moved at all. From a symbolic perspective, the Mulberries marked a turning point in modern warfare, the moment when victory depended not on seizing geography, but on creating it. For the first time in history, an army did not conquer a port. It brought its own. The lesson was not lost on the post-war world. Military strategists began to see logistics as the true measure of power. The Mulberries demonstrated that wars are not won merely by soldiers and weapons, but by those who can build the bridges, roads, and harbors that sustain them. In the weeks that followed, as Allied forces broke through the hedgerows and pushed toward Paris, the floating ports continued their quiet work, day and night, feeding the front with unbroken precision. For the Germans, every convoy that arrived was another blow to morale, not only because it carried men and machines, but because it carried proof. Proof that no wall, no storm, no coastline could hold back a nation that had learned to master engineering as an art of war. The beaches of Normandy were supposed to be a dead end. Instead, they had become a highway. By June 12, 1944, the miracle of Mulberry was no longer theory. It was alive, roaring, and unstoppable. From the air, the Normandy coastline had transformed into something that looked more like an industrial port than a battlefield. Ships queued in orderly lines offshore. Columns of trucks rumbled over floating causeways that bent and swayed with the tide. The rhythmic groan of steel joints and the hiss of hydraulic legs filled the air as cranes swung pallets of ammunition, crates, and fuel drums from ship to shore. To a German observer on the cliffs near Arromanches, it must have looked like madness, a mechanical organism growing out of the sea, expanding by the hour. They had been told the Allied invasion would choke itself on its own logistics. Instead, it was feeding itself faster than anyone thought possible. The weather during those first 2 weeks was merciful. Calm seas allowed the engineers to finalize the assembly of both Mulberry A at Omaha and Mulberry B at Arromanches. The Phoenix caissons stood like gray monoliths in the surf, their tops bristling with cranes and flags. Between them, steel roadways, the whales, arched gracefully toward the beach. Allied war correspondents who finally received clearance to film the scene described it as a harbor born in a week. Every hour brought new arrivals. Liberty ships, coasters, and tankers drifted into the artificial lagoon, their anchors clanking as they aligned with the floating pierheads. The spud pontoons adjusted automatically to the rising and falling tide, lifting their decks up to 20 feet in a day. On shore, bulldozers roared, carving roads and depots from sand dunes as streams of vehicles rolled inland. What no one outside a handful of Allied engineers knew was just how fragile it all was. The entire structure depended on a delicate balance of weight and motion. A single broken joint in a whale roadway could sever the flow of supplies. A sudden storm could tear the entire harbor apart. But for now, the weather held, and the operation reached its peak. In one 24-hour period that week, Mulberry A unloaded 6,000 tons of equipment and over 20,000 men. Mulberry B matched it almost ton for ton. The combined output exceeded what the largest ports in France had handled before the war. It was a triumph of timing, design, and sheer human willpower. From his headquarters in England, Winston Churchill received daily reports of tonnage and efficiency. When an aide remarked that it was astonishing the harbors worked at all, Churchill smiled faintly and said, "They had to. Failure was never an option." The soldiers who used the harbors saw them not as miracles but as lifelines. "We drove off a ship and never touched water," one American private recalled. It was like driving down a street back home. Only the street floated. For men who had fought their way off the beaches under fire just days earlier, that sense of order, of smooth, predictable motion, felt almost surreal. The Germans, meanwhile, struggled to interpret what was happening. Aerial reconnaissance revealed entire fleets moving through what looked like solid harbors. Reports sent to Berlin spoke of floating ports constructed by unknown means. Some believed the Allies had raised the sunken hulks of old ships to form breakwaters. A half-truth, since lines of scuttled vessels known as gooseberries did provide additional protection. But nothing in German engineering had prepared them for the concept of a prefabricated, modular harbor the size of a city. Even Adolf Hitler himself, when briefed on the existence of these portable ports, reportedly dismissed the notion as nonsense. His generals were less certain. Field Marshal Rommel, touring the defenses days before D-Day, had warned that once the Allies landed, they will build their own harbors. We must destroy them immediately. His warning had come too late. By the time the Wehrmacht realized the harbors were real, they were already fully operational. To Allied command, the success of the Mulberries meant something greater than logistics. It was proof that ingenuity could outthink fortification. The Atlantic Wall, built at the cost of millions of tons of concrete and steel, had been defeated not by brute force but by creative thought. As supply numbers soared, the invasion gained unstoppable momentum. The Mulberries fed the breakout from the beaches, allowing armored divisions to push toward Caen and the Cotentin Peninsula. Within 2 weeks of D-Day, over 500,000 men and 77,000 vehicles had landed in France, many through those floating piers. Photographs from the Time show. Allied soldiers walking across the flexible steel roadways, the sea rolling beneath their boots, trucks and tanks rumbling past. In the distance, ships lined the horizon. It was more than a port. It was a living bridge between continents, between desperation and victory. But even as it reached its peak, nature was stirring. The Atlantic, which had spared the invasion its wrath, was gathering its strength once more. Far to the west, barometers dropped, winds shifted, and waves began to rise. The storm that would test the Mulberries and the entire invasion was already on its way. On June 19, 1944, the weather changed without warning. A low-pressure system formed deep in the Atlantic and swept eastward toward Normandy. Fast, violent, and unseen. The Allied meteorologists had warned of rough seas, but no one expected what was coming. Within hours, the calm gray channel became a chaos of white foam and wind. Waves rose over 20 feet high. Ships tore at their anchors. The floating harbors that had defied enemy guns now faced a far more merciless adversary: nature itself. At Omaha Beach, Mulberry A, the American harbor, took the first blow. The storm struck with winds gusting at nearly 60 miles per hour, lifting the great steel and concrete structures like toys. Phoenix caissons that had taken weeks to sink were ripped from their moorings and tossed together, colliding with the groan of crushing concrete. Whales twisted, beetles capsized, and entire pierheads vanished beneath the surf. Crews fought desperately to cut mooring lines and release tugs before they were smashed to pieces. American engineers and Seabees struggled through driving rain to secure what they could. Bulldozers worked in water up to their axles, trying to anchor dislodged pontoons. But the sea was unstoppable. The next morning, the beach was unrecognizable. A graveyard of twisted steel, shattered concrete, and wrecked ships. Mulberry A was gone. The Americans would never rebuild it. 20 miles to the east, at Arromanches, the British faced the same storm, but fought back with grim efficiency. Mulberry B, the British harbor, was better protected by its position and slightly calmer waters. Its outer bombardment barriers held, absorbing the brunt of the waves. Still, enormous damage tore through the system. Engineers worked for 72 hours without rest, diving beneath debris-choked waters to secure cables and patch caissons with hastily welded plates. The scene bordered on the unbelievable. Waves broke over the tops of the Phoenixes, sending geysers of seawater across cranes and trucks. Men clung to ropes as floating bridges rose and fell 10 feet in seconds. Every bolt, every hinge, every weld was tested to its limit. When the wind finally died on June 22nd, the Allied command expected to find Mulberry B destroyed. Instead, it was battered but standing, scarred, listing, but alive. The British harbor would become the lifeline of the entire Normandy campaign. Its code name, Port Winston, soon became a symbol of endurance. The engineers reinforced the surviving caissons, re-anchored the piers, and widened the lagoon. Within days, operations resumed. By July, Mulberry B was handling more traffic alone than both harbors had combined before the storm. The loss of the American harbor was devastating, but not fatal. The Americans shifted their logistics strategy, using the open beaches as improvised ports. Landing craft were beached in tidal zones, unloading directly into amphibious trucks that ferried supplies inland. The flexibility of LSTs, landing ships designed to run aground and unload cargo through their bows, became crucial. But still, the backbone of the Allied supply chain remained the battered British Mulberry. From the German point of view, the storm seemed like divine intervention. Reports flooded into the headquarters of Field Marshal Rommel, describing catastrophic Allied losses at Omaha. Radio operators claimed the beaches were washed clean. For 2 days, the Wehrmacht dared to hope that the sea had accomplished what their artillery could not. But when reconnaissance flights resumed, the truth shattered that illusion. Photographs showed ships unloading once more, trucks rolling over repaired piers, and the massive breakwaters still standing like sentinels against the tide. The Allies had rebuilt their harbor almost as quickly as the storm had destroyed it. For German commanders, the realization was crushing. Not even nature could stop the invasion now. By August, Mulberry B reached its full potential. It handled 7,000 tons of supplies per day, including tanks, locomotives, and even prefabricated bridges. The harbor had become a floating city of 600 vessels, repair barges, fuel lines, workshops, and cranes, all synchronized in motion. The Phoenixes were coated with rust and battle scars, but they held. To the soldiers and sailors who worked there, the harbor became a world unto itself, a landscape of machinery and sweat, of diesel fumes and salt spray. Its decks never slept. Cargo moved day and night through fog, wind, and occasional air raids. By September, more than 2.5 million men, 500,000 vehicles, and 4 million tons of cargo had passed through the artificial harbors. The logistics chain was no longer a vulnerability. It was an engine of unstoppable advance. German officers visiting the Normandy coastline after the war were shown photographs of Mulberry B in full operation. Some stared in silence. Others shook their heads in disbelief. One remarked quietly, "We spent 4 years building walls. They built bridges." The storm of June 1944 had proven a final truth, that the victory in Normandy wasn't just about bravery or firepower. It was about endurance, adaptation, and the audacity to rebuild faster than the enemy could, react. What the Germans had dismissed as folly had become the very foundation of their defeat. When the last waves of the Normandy campaign rolled inland and France began to open before the advancing Allies, the Mulberry harbors had already achieved what no traditional port could. In less than 10 months of operation, they had landed the force that liberated Western Europe. 2.5 million men, 500,000 vehicles, and nearly 4 million tons of supplies. The figures were staggering. No other logistical system in history had sustained such scale, speed, and precision under combat conditions. By the time the port of Cherbourg was finally captured and repaired in late July 1944, Mulberry B, Port Winston, had already made itself indispensable. The damaged caissons were patched with new concrete, and every surviving whale bridge and beetle pontoon was reused and rotated in shifts. Engineers treated the harbor like a living machine, constantly mending, replacing, and rebalancing it. Even as winter approached and the seas grew rough again, the artificial port refused to die. To visiting generals, the sight remained surreal. Columns of trucks rolled off Liberty ships directly onto steel roadways that disappeared into the surf. Overhead, barrage balloons floated like silver guardians against Luftwaffe attack. Beneath them, hundreds of men worked ceaselessly, mechanics, crane operators, naval crews, and stevedores, all synchronized in a rhythm that never paused. It was a city of motion, one officer wrote. A city built on waves. The logistical consequences of Mulberry were immense. The ability to unload heavy armor, artillery, and vehicles directly onto the beaches meant that the Allied advance could proceed without waiting for permanent ports. Armored divisions that broke through at St. Lo, Patton's Third Army sweeping across Brittany, and Montgomery's push toward Caen, all drew their strength from the constant flow of fuel and ammunition that came through Arromanches. In military records, the tonnage moved by Mulberry B exceeded the combined output of all captured French ports in the summer of 1944. The Allies had effectively carried their own industrial port across the Channel and assembled it under fire. A logistical fantasy turned into iron reality. For the men who had built it, however, the recognition was modest. The Royal Engineers, the U.S. Navy's Seabees, and the British and Canadian construction crews returned quietly to their units after dismantling sections of the harbor in early 1945. Many never spoke of what they had achieved. When asked years later what it felt like to build a harbor in the middle of a war, one British officer replied simply, "We were too busy to notice." The Germans, studying captured documents after the war, were astonished by the foresight and organization involved. Post-war assessments by the Wehrmacht's engineering branch described the Mulberry concept as a stroke of strategic genius. German analysts noted that the entire Atlantic Wall had been rendered obsolete the moment the Allies proved they no longer needed ports to invade. The British Admiralty's final report on Mulberry concluded that the harbors had repaid their cost 100 times over. The project consumed roughly 1.5 million tons of material, the labor of 40,000 men, and months of industrial production. Yet it shortened the war by months, perhaps longer. It was a rare instance where engineering alone changed the outcome of a campaign. By the end of 1944, as Allied forces advanced toward the Rhine, the Mulberry structures were still in use. Battered, patched, and rusting but functional. Even as new continental ports reopened, Port Winston continued to offload convoys until December, long after its designers had predicted it would fail. It outlived the battle it was built for. When it was finally dismantled in 1945, some of the caissons were towed away to repair other harbors. Others were left behind, half submerged off the coast of Arromanches, where they remain to this day, silent monuments to an impossible idea that worked. They had brought the ports with them, and with them they had brought victory. When peace finally settled over Europe in 1945, the Mulberry harbors faded quietly into legend. No victory parade marked their achievement, no marble monument recorded their names. Yet, for the soldiers and sailors who had depended on them, their memory remained vivid, a vision of steel and concrete that turned the tides of war. In the post-war years, historians came to understand that the Mulberries had not merely supported the Normandy landings, they had made them possible. Without those artificial ports, the Allied armies would have faced crippling delays, supply shortages, and exposure to counterattack before Cherbourg or Le Havre could be captured. Logistics had been the invisible weapon of victory, and Mulberry was its masterpiece. After the war, much of the surviving material was salvaged. Some Phoenix caissons were towed back to Britain and used to repair bombed-out docks at Southampton and Portsmouth. Others were repurposed to form new sea defenses along the English coast. Yet many were left where they had served, silent. Barnacle-covered hulks rising from the tide off Arromanches, a skeletal reminder of the day when men built a harbor upon the sea. The engineers behind the design finally received recognition in later decades. Alan Beckett, whose flexible Whale Bridge system had held the harbor together through the storm of June 1944, was quietly awarded honors for his contribution, though he never sought them. Others, like Hugh Ioris Hughes, who designed the Phoenix caissons, and the countless anonymous workers who built them in shipyards across Britain, were remembered only in the technical archives of the Ministry of Works. Their fingerprints, however, remained stamped into the concrete still standing in the Channel. The strategic legacy of Mulberry reached far beyond Normandy. The concept of prefabricated, modular, and floating logistics inspired military engineers for generations. During the Korean War, American forces adapted similar pontoon causeways for amphibious landings at Incheon. In later decades, the principles of Mulberry construction would influence everything from oil platforms to offshore wind farms, any structure designed to resist the sea while remaining mobile. For the Allied nations, the harbors symbolized a new kind of power, not the destructive power of weapons, but the constructive power of organization and foresight. They embodied a truth often forgotten in war, that battles are won not only by the courage to fight, but by the ability to sustain the fight. The Mulberries had turned the tide not through violence, but through engineering. In Arromanches, the remains of Mulberry B still mark the horizon. Tourists stand on the beach today, watching the tide draw back to reveal the vast concrete ghosts lying half-submerged in the sand. Fishermen navigate between them, their nets brushing the same walls that once sheltered Liberty ships and landing craft. At low tide, children climb onto the barnacled blocks, unaware that they are standing on the bones of a miracle. Inside the small museum overlooking the bay, old film reels show grainy footage of the harbor's construction. Tugs towing caissons, soldiers driving across floating roads, cranes unloading trucks onto the beach. Visitors watch in silence as the impossible takes shape again, frame by frame. What remains of the Mulberries is not merely a relic of war, but a monument to human imagination. In the darkest chapter of the 20th century, when Europe lay divided by barbed wire and ruin, engineers found a way to make the sea itself an ally. Their work had no anthem, no speeches, no glory. But every man who marched through France that summer, every tank that rolled, every convoy that reached the front, owed something to those quiet structures floating off Normandy. Time and tide have reclaimed much of what they built, but when the water recedes at Arromanches and the concrete giants rise again from the surf, they remind the world of one enduring truth, that in war, as in peace, imagination is the greatest engine of victory. In the long shadow of D-Day, historians would speak of courage, of sacrifice, of strategy, but the quiet rhythm that kept the invasion alive was the pulse of logistics, measured in steel and tide. The Mulberry harbors were not monuments of conquest. They were acts of faith, faith that the laws of the sea could be bent to human will, that organization could overcome chaos, that imagination could bridge the unbridgeable. For the Germans watching from their bunkers, the sight had been beyond reason. Ports that floated, piers that rose and fell with the waves. In their reports, they called them Wunderhafen, miracle harbors, not realizing that the real miracle was not magic at all, but method. Thousands of hands, hundreds of minds, all synchronized across months of secrecy, had made the impossible routine. Long after the guns fell silent, the lesson remained. War had entered a new age, one where victory depended less on the size of armies and more on the speed of supply. The Mulberries proved that the future would belong to those who could build faster than the world could break. Their remains still rest off the coast of Arromanches, gray and barnacled, half swallowed by the sea they once tamed. At low tide, their shapes rise through the mist, not as ruins, but as reminders. Reminders that on a June morning in 1944, human ingenuity turned the waves themselves into allies, that an army without a port built one, that the greatest engineering project of the war was not about destruction, but creation. The Germans never expected harbors to rise from the sea, and yet they did, carrying across the channel not just men and machines, but the proof that imagination, when wedded to purpose, can alter the course of history.